Hi there, and welcome to the second video for week 1 of EG1311 Design and Make. In this video, we're going to talk a little bit about the laboratory and lab safety in the laboratory. So this is the layout of what the E40206 lab looks like. There's a long hallway on the second floor of building E4, and right at the end of that hallway is a door. The entrance here swings out here. And when you go into the lab, you've got a big workshop with lots of dangerous looking machines. You don't get access to any of those. There's an office where the lab staff is, and there's a room for the laser cutter, and there's some 3D printers in there. We don't get to use the 3D printers, but we'll get to use the laser cutters. And then this is the main area where you guys will be doing your thing. There will be at most 6 teams in each lab section. And each of you will have one of these hexagonal tables for 6 of you in each team at most. So that's the layout of the lab. Just in terms of rules in the lab, I'll remind you guys not to bring food or drink in the lab. If it's contained and you're going to eat it later sometime, that's okay, as long as it's not out and could be spilled or contaminated by things in the lab. In terms of attire, this is a lab policy that's not just for this lab, but for many labs around NUS. We request that you not have any open-toed shoes, closed toe and closed back, as well as no shorts or short skirts. So please wear long pants or long skirts so that you're not going to get the lower part of your body exposed to anything you might have in lab. And don't sit on the tables. So the lab that we're sending you to is not a particularly dangerous place, but these are just a good rule of thumb whenever you're going to a lab space here at NUS. So aside from covering the basics of the rules for our laboratory, we're all just going to watch a quick safety video that NUS, they ask us to have you watch. So sit back and watch this brief safety orientation on safety and health at the lab.
Welcome to NUS. You're about to embark on some fascinating work at the laboratories and workshops here at NUS, and we are sure you are excited to get started. Before you begin, let's talk about safety and health in laboratories. In NUS, we embrace safety and health as one of our core values. And therefore, we must all take ownership of safety and to make NUS a safe place to study, work, and live in. That means proactively thinking about safety and following safety rules and practices. This is especially important when you work in the laboratories, where you might be exposed to a diverse range of hazards. So how do you keep yourself safe while working in a laboratory? You need to follow the safety and health policies and procedures of the laboratory, which are derived from the risk assessment process. Risk assessments are an integral part of campus safety and are to be conducted before the commencement of any activities in the laboratory. The process typically involves 3 steps: identifying the hazards arising from the activities, evaluating and assessing the risk level of these hazards, identifying and implementing additional control measures to mitigate these risks. Let's take a look at each of these 3 steps in more detail. The first step in the risk assessment process is identifying the hazards present in an activity. A hazard is anything that can cause potential harm to you or others. Hazards can arise from the equipment that you use, the procedures that you do, or the agents and materials that you use. As you work in the different laboratories throughout the campus, you will encounter various types of hazards, such as physical, electrical, fire, chemical, biological, and radiation hazards. Once the hazards have been identified, the next step is to evaluate and assess risk levels. Risk level is the product of the likelihood and severity of the hazard causing injury or ill health to you or others. Let us use an example to illustrate this point. Glassware is handled frequently in laboratories and a common hazard is broken or chipped glassware. Anyone handling glassware is at risk of cuts and lacerations. To determine the risk level, you would need to identify the factors that could influence the likelihood and severity rating of the risk. For example, the likelihood would be higher if the person handling the glassware is inexperienced, and the severity would be higher for an eye injury against a skin injury. Once the risk level is evaluated, the next step would be to determine additional control measures to reduce the risk level. In this step, we use the principles of the hierarchy of control to determine the reasonably practical additional risk control measures. According to the hierarchy of control, the most preferred control measure is to completely eliminate the hazard. For example, getting rid of clutter on a laboratory or workshop floor will eliminate slipping and tripping hazards. The second most preferred measure is substituting the source of the hazard. For example, using a chemical that is less flammable in an experiment will reduce the risk of a fire. The next choice of control measures is engineering controls. These are devices or barriers installed or incorporated into equipment or processes so as to isolate the hazards at its source. An example of an engineering control is a fume cupboard, which protects the user by extracting potentially hazardous vapors or gases. Another example is machine guards on equipment, which protect the user from moving parts or projectiles. Next on the hierarchy of control are administrative controls. Examples of administrative controls are laboratory rules, standard operating procedures, emergency procedures, and training programs. In NUS, any staff or student working in the laboratory is required to undergo mandatory safety and health training. These include online university-level training, faculty, departmental, and laboratory-specific training. So do familiarize yourself with the training requirements of the laboratory that you are working in. The last and least preferred control measure is the wearing of personal protective equipment, or PPEs. Common PPEs such as laboratory coats, safety glasses, and covered shoes are often the last line of defense against hazards. Always follow the PPE requirements of the laboratory, which can be found on the signage posted at the door of every laboratory. Now that you have familiarized yourself with the risk assessment process and how the various control measures reduce or manage this risk, it is important that you do your part in implementing these controls. You can start right now by doing the following. Attend the necessary safety training before working in the laboratory. Keep yourself abreast with all the requirements of the laboratory safety manuals and standard operating procedures. Report any accident or incident to your principal investigator or supervisor immediately. You are also required to submit a report to the Office of Safety, Health and Environment within 24 hours. Remember the following emergency contact numbers. For more information about safety and health requirements for working safely in laboratories, please refer to the website of the NUS Office of Safety, Health and Environment. You can also get in touch with your laboratory's safety leads or supervisors for more guidance on health and safety. As a leading university in Asia, NUS is committed to maintaining a safe working environment for everybody. We invite you to embrace the NUS safety culture starting from today and to carry it on into your future professional careers. Let's work together to create a safe and healthy campus.
All right, so that's safety here at NUS generally. Now let's talk about how the things from that video apply to the EG1311 lab in particular. Now, the EG1311 lab is not such a dangerous place, like I was saying before, but you will be using some hand tools like a penknife, a hot glue gun, and batteries where you might incur some low voltage shock. Nothing that could be particularly life-threatening, but things that could make you uncomfortable. So a cut from the use of a handheld penknife, very low temperature burn from the use of a hot glue gun, or small, shocks from the electronics we're going to be using. So when we're evaluating a risk level for a particular activity here at NUS, we say that the risk is the product of the likelihood and the severity of that risk. And here at EG1311, the severity of the risks that are involved in participating in these labs is quite low. We rate them at a severity level of 1, but the likelihood is, relatively probable. Is it likely that some student among the 750 of you will get a small cut from a penknife during your 13 weeks of this course? It's pretty likely, but luckily the severity of those things are not so damaging. And we have first aid kits and things like that in the lab. So please just, if one of these things happen to you, go and seek out one of the lab staff and we can get you all patched up. But because there's a low severity and a relatively low likelihood that these things could occur, that risk level is assessed to be the product of 1 and 2 or 2. And risk of a 1 or 2 is considered a low risk here at NUS, and no additional controls are required except for us informing you of those risks and training you on how to deal with them. Now we're going to go ahead and talk about some of those different aspects of safety, starting with different ways to use a penknife in a safe way. It's important that you always cut on a cutting surface or a cutting mat when you're using the penknife. Don't cut directly on the lab benches, and make sure that the cutting mat is stable and unobstructed before you start using it. Make sure the penknife is in good condition before you start using it, that it's not damaged and there's not anything loose coming off of it. And make sure to lock the blade in place using the locking mechanism before you start cutting. Make sure to hold the handle securely to maintain control while you're using the penknife, and hold the knife at a 45-degree angle and apply firm pressure. It's important that you also use a ruler to make clean, straight cuts through the material that you're cutting, and don't force the blade through the material. Be controlled and moderate with your pressure. Take your time, don't rush it, cut slowly so that the product that you make can have high quality. Make sure that when you're using the penknife that you always cut away from your body to avoid injury, and ensure your fingers in particular are not in the path of the blade when you're using it. Now, when you're done using the blade, make sure you fully retract it when not in use, and don't play around when you're holding the knife in your hands. Don't engage in horseplay. Now, when it comes to the hot glue gun, the things you need to remember about the hot glue gun is that it needs about 5 minutes to heat up before you can start using it. Don't plug it in and expect to immediately start using the glue gun, because the glue is not yet hot. And so it won't stick to the material that you're trying to stick together. When you're not using the glue gun, make sure that you stand it upright on its kickstand. Don't lay it on its side in case the heating elements interact with the things on your workbench. When you're using the hot glue gun, always make sure to keep it pointed in a safe direction. And then when you're applying force to the trigger, don't use excessive force and apply a light pressure to slowly release hot glue from the nozzle onto your workpiece, no more than you actually need. Now, it's important when you're using the hot glue gun not to touch the hot glue gun nozzle or any of the melted glue that comes out before it's dried, because otherwise you might get burns if you have the glue contact your skin. And make sure not to leave your gun plugged in while unattended. Always be around if it's plugged in. When you're done with it, make sure you unplug it, turn it off, and let it cool before you put it back away in your bag. And lastly, when it comes to electrical safety, make sure that the various plugs that we've given you that are 2-pin plugs Don't plug those 2-pin plugs directly into any of the lab outlets in the lab. That's a safety hazard. Make sure that you're using some of the 3-way multi-adapters that are built for accepting 2-pin plugs that are provided at each workbench at the lab. Now, before you're using the batteries, ensure that they're not damaged before you're using them. Make sure they don't have any burn marks on them and they're not hot to the touch or anything like that before you're using them. Don't tape or glue anything to the batteries. That will help ensure they're not being misused. And make sure that when you're not using the batteries, that you unplug the batteries from their holders so that you don't accidentally short them. And what we mean by shorting the battery is that every battery has a positive and a negative end. It's important that you don't short circuit that with some metal. If you do short the ends of the battery, it will have large amounts of current flow from one terminal to the other, causing lots of heat and potentially burning you or damaging the battery. So if any component that you're using becomes hot, make sure you unplug power to it ASAP so you can figure out what shorted or what may have gone wrong. Okay, so that's lab safety here at EG1311. In order for us to confirm that you viewed this video and have been informed of the safety requirements of EG1311, we have an online form on Canvas called the safety form, where you need to provide some personal and emergency contact information and verify that you are aware of the risks of using the laboratory facilities. And it's important that you fill this form out prior to the start of your first laboratory session, because the lab staff will not allow you into the lab unless you have a safety form filled out. So please do ensure that you finish that, preferably within week 1, so that you can be all set to be with your team in your first laboratory session. So that's the end of our second video. Please stay for a brief quiz.